problem, I am doing number 10. I'm sorry, number 6. I said 10 because it's super late. It's 10 o'clock. All right, if you're still with me, you rock. You're amazing. If not, maybe you're watching this. I don't know. Maybe you're watching it in the morning. I don't know. Let's see. We'll see. Let's see. All right, so I've got 3 functions. I got a g function. Boom. I got an h function. Boom. I got an f of x function. Boom. My g function was given as a table. My h function was given as an equation, and my f function was given as a graph. They also gave me the equation, but pictures are so easy to read, so I like the graph. All right, our first question asks us, Riley claims that the h of 3 is less than the f of 2. Well, let's look at the h of 3 and the f of 2. So the h function I'm looking at here, and the f function I'm looking at here, and they want me to evaluate when when x is 3 versus in the f function where x is 2. Okay, so I go to my equation and I'm going to plug in x. I'm going to plug in 3 for x. So this is going to be 5 times 3 plus 4. This part is just notation, so this just stays the same. So the h of 3 is equal to 5 times 3, which is 15 plus 4. 15 plus 4 is 19. Okay, so Riley says that h of 3 is less than the f of 2. So far we got the h of 3 is 19. Let's see what the f of 2 is. So I need to figure out when x is 2. So here's a graph. Your x-axis is here. So I'm going to go, oh man, my TV just started. I'm recording everything, right? I'm watching This Is Us. It's one of my favorite shows. I'm definitely watching it before I go to bed, which means I'm probably going to look like I cried my eyeballs out tomorrow. Okay, anyway. So x, the x here, I'm looking for where the x is 2. Here's 2. What's my output here? What value is this? This value is 4. My value is 4. So when I go to my x of 2, I get 4. So I'm comparing 19 and 4. And Riley apparently is saying that 19 is less than 4. Do you agree with that? You should put a big X through that. No, we don't agree with that. So is Riley correct? No. And we want to make sure we answer the question. Riley, in fact, is incorrect. And we are going to say, because, and then I'm going to write here, the h of 3 is equal to 19, and the f of 2 is equal to 4. And 19 is greater than, and you can use symbols, of course, than 4. We know that. And that's just that simple. Let's look at the last one. Again, you can rewind and pause as you see fit. All right, so then Juan's over here and Juan's making claims. Juan says if the x value for all 3 of these functions is -1, see, you plugged in -1 here, -1 here, and -1 here. If the x value is always -1, he says that for each function, my output's going to be the same. When I plug in -1 here, and I plug in -1 here, and I plug in -1 here, they're all going to be equal. So let's go back to our functions and see what happens when x is -1. When x is -1, what's my output here? 1. So far I have the g of x, and don't get too dizzy. I've got the g of -1 is equal to 1. All right, let's go to our h function. What happens when I have the h of -1? Well, we got to plug it in. So this is going to be equal to 5 times -1 plus 4. 5 times -1, you say to yourself, is -5 plus 4. -5 plus 4 is -1. Hold on, Juan. Let's look. Juan said if I plug in -1, I should get the same thing, but we got -1 when we plugged it in. See, we got -1. All right, now let's go to the f function. Juan says, well, so far we know he's wrong so far. But if I go to my x-axis and I go to -1, so let's go to -1, which is here. And I go up, my output is not 1. My output is actually like 1/2. This is actually like 0.5. All right, so then we know that the f function at -1 when I evaluate it is 0.5. Is Juan correct at all? Are any of these equal? No. So Juan 2 is incorrect. We've we've written y, but we can simply say, for someone that maybe can't necessarily read, 1 is not equal to -1 and it is not equal to 0.5. None of these are equal to each other. Okay? And that is it.